Hey, so this is going to be a really quick video. I just want to go over essentially what the conditional, converse, inverse, contrapositive statements are and how we can use those in a mathematical proof. And just explain why certain things are logically equivalent. So say we're trying to show that two even integers added together is going to be another even integer. Well, we define what's even, 2k plus 2l, and we algebraically show that that's going to be another even integer, therefore divisible by 2. But sometimes we have more complicated situations where we don't necessarily have a definition. So we have a definition of even, odd, rational, but if we have a proof saying, show that the square root of 2 is irrational, well, we don't have a definition of irrational, but we can say that a rational number is a ratio of integers a over b when b is not equal to 0. So we can prove that, but we can't prove it rational. So we'd use an inverse, and we'd do a proof through contradiction, and we'd show that, well, suppose that the square root of 2 is rational, and then show that there's a contradiction in that statement, or in the proof of that statement. But we need to show that, well, the inverse is going to be the opposite of the conditional, and we need to show that the converse is going to be the opposite of the contrapositive. Now, in comparison to that, the contrapositive is going to be logically equivalent to the conditional, and the converse is going to be logically equivalent to the inverse, and we can use this in a lot of different ways in a proof. So to show that, I've just drawn out a quick truth table here, and the idea is that, well, we have every possibility of relationship of truth and false between P and Q written out here. So we have both P and Q are true, P is true, Q is false, so on. But you can see in the values here, if you have P is true, therefore Q is also true, 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 so forth. Well, the truth table here for this is the, just to clarify, this is our conditional statement, this is our converse, this is our inverse, this is our contrapositive. And if you look at these, well, for our conditional we have a truth, false, truth, truth. And then for our contrapositive we have the same string of truth and false. So we have true, false, true, true. So from this we can see that the conditional and the contrapositive are logically equivalent. If we look at the converse and the inverse, here we have the converse, here we have the inverse, we can kind of see here that, well, true, true, false, true. So the converse and the inverse are logically equivalent. I hope this kind of clears things up. I know personally when I was learning this stuff I messed it up a lot, and this is a big issue on proofs. So yeah, just something to see, something to think about. Hopefully it helps you clarify things and work through things better when you're doing them.